is, Zeckendorf decompositions and games. So by now, everybody has hopefully read, some of the basic papers in the literature on, what is a Zeckendorf decomposition and how can we use this to create a game. So the standard one is, we start off with bins F1, F2, F3, F4, F5, and so on. And we have, some number of pieces on each one. So maybe we start with, 4 things at some point here, 2 things here, 1 thing here, 1 thing here, and so on. And we have 2 possible types of moves. We can take 2 pieces that are adjacent, and we can move them to the next square and then just delete what we had before. So that would be one possible valid move. And so that move is, say fn minus 1 plus fn. We replace that with fn plus 1. And we often use like a wedge to denote and here. The other thing we could do is we could do a split move. So imagine we have 2 pieces on F4. What we could do is we could take those 2 pieces and put one on an F5 and then move 1, 2 back. And that's using the rule fn would go to fn plus 1, fn minus 2. And if you think about this, 8 plus 8 is 16, which is 13 plus 3. And if we look at the Fibonacci numbers, 1, 2, 3, 5, 8, 13, 21, 34, and so on, we see 13 is the next one after 8, but the 3 is too earlier. This causes, unfortunately, some issues, because if we try to put something at the 2, we would get something on F3 and something really on F0. And with this notation, F0 would really be another 1. So I don't want to go into too much of that right now. But these are the 2 splitting rules we have. And the first
Professor Miller, it seems that your microphone, was shifted for a bit, so you were a bit muted.
Thank you. Okay. Did you hear the part about splitting the 16?
We heard part of it.
Okay. Let me just quickly then re-say it again. So if we have 2 things on Fn, that's the same as something on Fn plus 1 and something on Fn minus 2. So for example, 8 plus 8 is 16, which is 13 plus 3. And one of the things that's a little bit annoying is that if we have 2 things on F2, if we really want to view how should we split F2, well, F2 plus F2, that's 2 plus 2, that's 4. We can view that as 3 plus 1, or F3, and we should really view it as an F0. We don't have an F0, so we replace this with F1. And we really want to move things down, 2 indices for the other one using the recurrence relation, but we don't have an F0. We're defining the Fibonacci sequence as 1, 2, 3, 5, because if we had 2 1s or if we had a 0, we would lose uniqueness. So what's fascinating is this game is very simple to state. We can prove that player 2 has a winning strategy as long as there's at least 2 points on F1. The game always ends in the Zeckendorf decomposition. And so the question is, what other games can we consider along these lines? One of the games that has been suggested is to consider an accelerated version of this, where if you're doing a split or a combine, you can do multiple ones of those all at the same time. What I would like to do today is talk about a higher dimensional analog. And before doing that, I'd like to look at a simpler one-dimensional version. So imagine, I've got my Fibonacci numbers, F1, F2, F3, F4, F5, and so on. And now, what if we considered slightly different rules? So right now, the rules we have is if I give you 2 things that are next to each other, I can take them and replace them with something 1 higher. Or basically, if I have two things on the same, I can move one up one and one down two. If you were coming up with rules, I think the first rule is a very nice one. Take two things next to each other and push it forward one. But for the second one, if you take two things that are doubled up, you push one forward one and you push the other back two. If you were creating the universe, would you do back two or would you do something else? What would you do instead? Any thoughts? So what might be simpler than moving one forward one and one back two? Move one forward one and move the other back.
You'd want to move it back one, but then the sum wouldn't be preserved. So
But we don't have to view these as Fibonacci numbers. We could just view these as we just have general positions. You know, we just have a bunch of boxes, right? So what if we just view them as a bunch of boxes and we have these rules? Will the game still end? Will it end in some kind of decomposition? So my first question for you is to see if you can analyze what would happen in this tweak. And then that might give you a better sense of, you know, why the rules are defined the way they are. So try to figure out what would happen if instead we use these as the rules. The next thing is to try to find a two-dimensional version. And again, there has been some work on Zeckendorf decompositions in the plane, but everything we have does not yet have a unique decomposition. It turns out that when we do this, lots of numbers have multiple ways of being decomposed. I don't want to share those papers with you right now because I want you to just consider this as a formal problem and see if you can come up with some ideas. I'll give you a little bit right now, but I want to try to give you a chance. And then if you truly get stuck, you know, I'm happy to share those papers and maybe we'll use those to build a two-dimensional game. So I take some kind of, you know, infinite lattice and I need to define some rules. And so if I have two pieces that are adjacent, can somebody give me a possible rule?
get rid of them and then move it to the next one across the same line that they
Yeah.
are facing on.
Yeah, so maybe we just replace them and move them over one. And similarly, if we had, probably have a lot more black dots. You know, maybe similarly, if we had two pieces that were vertical, we could do the same thing. So then the next question is, what would you want a split move to be? So this is the combine move. Now we have to figure out what should a split move be. I mean, it's okay if what you propose doesn't work well, but just right now propose something. So you would need to tell me how many pieces I need on a given bin to split. And then how do you want to do the split?
Do you mind if I try to comment, or should I leave this to the researchers?
Let's give the students one more chance.
Okay.
And then if they don't have any idea, then by all means, feel free to comment. But, any student want to make a conjecture, in one dimension, we had two things and we split by moving one to the right and two things to the left. What rule might you want to try in 2 dimensions? It's okay to be wrong. You can propose anything. Since there's no game, there's nothing that's wrong. So how many pieces would you want to put in a spot? It's got to be at least 2. Do you want 2? Do you want 3? Do you want 4? Do you want 5? What might you do? So somebody needs to be brave enough and try something. Some student, give me a number of points you want to have.
Somebody mentioned in the chat, Chenjiang Zhao mentioned in the chat, 1 up and 2 down, maybe.
Okay, so if it's 1 up and 2 down, then that would be having 2 pieces. So that's absolutely one possibility. So we could have 2 things here, and we could go 1 up, and we could go 2 down. That's one possibility. That preference is going up versus down, but that's fine. That's one possibility. What's another possibility? If we could do it that way, we could also do it 1 to the right, and then 2 to the left. Or another possibility is maybe we have 4 things here, and maybe we take the 4, we move 1 up to the left, 1 to the right, 2 down, and then 2 over. There's lots of possibilities. And so we can play this with just a game on a pegboard. And it could be the case that if we play this as a game on the pegboard without taking into account that these are coming from Fibonacci's or some generalization of the Fibonacci's, we might not come up with the right moves. And so in the first game, the right move turned out to be, going back 2, not back 1. So I'm trying to give you, a little bit of a, chance to explore and control what do we study. It's not clear. Maybe we want to have 2 types of moves. Maybe we want to have the vertical split, and that's 1 up, 2 down. The horizontal split, and that's going to be 1 right and 2 left. So that's one possibility. Or maybe we have 1 up, 1 right, 1, 2 down, 1, 2 left. Maybe that's the right way to look at things. So your question will be, can you come up with a good game? And so what properties do you want a good game to have?
You'd want the game to end.
Good. That's the most important thing. I want the game to end. So can you come up with a set of rules that will have the game ending? And in order to do this, we might need to have some kind of structure about what these numbers are. And that might influence then which moves are possible. This idea of having 4 pieces and 1 goes up, 1 goes to the right, and the other 2 go down 2 or left 2. It's a natural thing to try, but maybe that's not the right thing. We could, of course, try the simpler where 1 goes to the 1 goes up, 1 goes down, 1 goes right, 1 goes left. So anyways, this is a set of possible things to try. And what's nice about this is there's not too many prerequisites or background material needed to start this project. And then we've already received, some other emails about possible projects. And so what I think everybody should do is, spend the rest of today and tomorrow thinking about what you're interested in, and then email the group of which projects you're most interested in, second most interested in. So any questions on what I've just displayed tonight? Okay, any questions about the problems that the other mentors have passed along?
Yeah, actually, Professor, I have a question about this.
Yes.
Yeah, so while we were ranking or choosing our which products we were kind of interested in, do we just follow what the previous students have done, or what the mentors have proposed to us, or can we also come up with a new project with our new idea that we think might be a nice a new way to look at this? Yeah.
As long as it's related to what we're talking about, to the stuff that the mentors and I have passed along, run it by myself and the mentors. We're
Okay,
supervising a lot of students. We're absolutely thrilled if there are some
yeah.
things that you're inspired to do. If we use these problems as a springboard, that's absolutely wonderful. We just can't mentor 7 completely different projects on this, because we also have other people in number theory and probability doing other problems. So if we can find a way to make it work, especially if other people are interested in it, then that's great, and we're happy to do that.
Okay. Okay, that would be really cool. Thank you, Professor.
Yep, you're welcome. Anything else? Okay, so I will, wish. Oh, yes.
Yeah. So yes, still just continuing my last problem. So yeah. So do we have like a list of do we have a list of problems that do we have a list of like projects we can do regarding to this problem that were sent to us, or have those kind of like ideas already been sent to us?
So they've already been emailed, except for the ones I just mentioned right now.
Yeah, okay. Yeah, right. I see. I just did not see the last one you mentioned. Okay, thank you.
Yes. So this was a new one. I just wanted to put one more possible project in the mix.
Okay, thank you.
And then maybe
Professor.
one of the mentors can just send a quick summary to everybody about what the different problems are that have been thrown out. Okay, any other questions? All right, well, looking forward to getting to know you more over the summer and investigating things. Have a great rest of the day.